Welcome to the deep dive. When you look at modern manufacturing industrial control, it's always been, well, incredibly complex, right? Building and managing these automated systems, often really difficult, costly, and sometimes just plain rigid. But what if there was maybe an open source way, something poised to shake things up, make complex automation, agile, like modern software? That's exactly what we're plunging into today. Eclipse 4diac, it's the open source reference implementation for a really critical standard called IEC 61499. So our mission here is to get you quickly up to speed on how this tech simplifies those complex control systems, who's actually using it, and frankly, why it's becoming such a big deal in smart manufacturing and, well, beyond. Let's dig in. Okay, so first things first, we're talking about a standard, IEC 61499. At its heart, it's designed for controlling cyber-physical systems, CPS.
Right. And cyber-physical systems, when we talk about them here in this industrial context, think of it like the nervous system of a smart factory. These are systems where the physical bits, the machines, the robots, sensors on the floor, they're deeply, intricately woven together with software components. It's all about that real-time, seamless interaction between, the physical world and the digital world. Super crucial for everything from automated production lines to, say, smart grids.
Okay, got it. And that's where Eclipse 4diac comes in.
Exactly. It sips right into that space.
So it's not just theory, it's the practical open source way to actually do IEC 61499.
Precisely.
And it's got some history, right? It started back in 2007, became an Eclipse project in 2015, so it's pretty well established.
Yeah, it has a solid foundation. And being an Eclipse project under the Eclipse public license, that's particularly compelling.
Why is that specific license so important here?
Well, it's not just about having the code available. This license, it explicitly allows people to use it in commercial products. You can even build proprietary extensions on top of it.
Ah, okay. So companies can use this open core but still add their own secret sauce.
Exactly. It's a huge deal. It fosters really widespread adoption, encourages innovation. Companies get this robust, open foundation, but they can still protect their unique value add. It really helps democratize complex industrial automation.
Okay, so it's open, it's flexible. How does it actually work? I understand there are two main parts.
That's right. Eclipse 4diac is basically structured around two key components. You've got the 4diac IDE and then 4diac 4TE.
The IDE, that sounds like the development environment, like where you actually build the applications.
You got it. Think of it as the design studio. That's where engineers visually lay out their control logic. They design and configure the brain of the industrial process, deciding how everything should behave.
Visually, so less like traditional coding.
Often, yes. Using function blocks and connections, which aligns with the IEC 61499 standard. It can make things more intuitive for control engineers.
Okay, and the other part? 4diac Forte.
Ah, Forte. That's the hardware abstracting execution environment. This is where a lot of the magic happens, really.
Hardware abstracting, meaning?
Meaning it acts like a universal adapter. You design your application once in the IDE, right? And Forte handles the messy details of talking to different hardware. It lets those applications you designed run on a massive variety of devices without needing to be rewritten for each specific piece of kit.
Okay, that sounds incredibly useful. It makes your applications portable, future-proof, maybe?
Absolutely. That's the goal.
And when you say a huge variety of hardware, what are we talking about?
I mean, it really spans the gamut. 4diac Forte supports everything from hobbyist boards people might know, like Lego Mindstorms, EV3, Raspberry Pi.
Oh, really? Even those?
Yeah, all the way up to serious industrial-grade PLCs, programmable logic controllers from the big players. Companies like Bachmann Electronic, Bosch Rexroth, Phoenix Contact with their PLC Next, Wago. It's that breadth of compatibility that's really impressive.
Wow. Okay, so from maker projects to heavy industry.
Exactly. And to really drive home that flexibility, 84IT also runs on a truly wide range of operating systems. You've got the common ones like Windows, various Linux distributions, POSIX compliant ones like Cygwin, standard Linux on different architectures, plus real-time operating systems, things like FreeRTS, VxWorks, which are critical in many industrial settings.
So it can run pretty much anywhere you need it. Small embedded sensor, a big factory controller.
That's the idea. Unmatched adaptability for all sorts of environments.
So we know what it is, where it runs, but, the real power in automation often comes down to how things talk to each other, right? Getting different machines, maybe from different companies, to communicate seamlessly, that's always been a massive headache. How does 4diac handle communication?
That's a critical point, yeah. And 4diac tackles it head on. It supports a really extensive list of communication protocols right out of the box. Think of it as a kind of universal translator for industrial gear.
Okay, like what kind of protocols?
Well, the basics you'd expect in industry: Ethernet, so TCP/IP, UDP, things like Modbus TCP client, RS-232 for serial comms. But crucially, it also integrates modern IoT and industry standards. MQTT is a big one, often through Eclipse PAHO, OPC-DA client too, and very importantly, OPC UA, also leveraging the wider Eclipse ecosystem.
LPCUA, that's becoming huge for interoperability, isn't it?
Absolutely essential for Industry 4.0 type scenarios.
And are they looking ahead, adding more?
Definitely. What's quite forward-thinking is their roadmap. They're looking at integrating with, cutting-edge data streaming platforms like Kafka, also DDS, the data distribution service, probably using Eclipse Cyclone, and
Yeah.
something called PPMP from Eclipse Unite.
So they're not standing still. They're building in future compatibility.
Right. It shows a real commitment to keeping industrial systems at the forefront, especially with the whole industrial Internet of Things taking off.
That makes sense.
And, this commitment, it's not accidental. A key thing about 4diac is that it actively functions as an incubator for extensions to the IEC 61499 standard itself.
An incubator? How so?
Well, they pioneer things like untyped sub-applications, simpler function blocks, ways to integrate better with the older, but still widely used IEC 61131- standard for PLCs. So 4diac isn't just using the standard, it's actively helping to shape and evolve it, keeping it relevant, making it more powerful for future challenges.
Okay, so this standard and 4diac implementing it, they're directly tackling some big industry problems, and maybe the biggest one, the cost and complexity of software. That seems to be exploding.
Well, it's absolutely a dominant concern. There was this industry report quite a while back, actually, from IED in 2006. Starkly illustrated this. It predicted that the software engineering part of the cost for making a machine could jump from like 50% up to maybe 80% by 2020. That's a huge chunk of the cost shifting to software.
80%, wow.
Yeah. And then another quote, this one from SPS Magazine in 2012, it really highlights the pain point manufacturers were feeling. It said something like, we've mastered most topics, saved up to 70% on engineering effort elsewhere, but the software effort, that still gives us problems.
So even when they optimize everything else, the software remains the big hurdle.
Precisely. These figures just clearly show that software became the most resource-intensive, the most challenging part of building modern manufacturing systems.
Okay, so how does IEC 61499 help with that specific problem? You called it a domain-specific modeling language.
Right. For distributed industrial process measurement and control systems. It's a mouthful, but basically, think of it like having a specialized blueprint language designed just for factory automation.
Okay.
Instead of trying to write thousands of lines of complex, maybe error-prone code from scratch every time, you're using visual blocks, connecting them, describing how machines should behave at a higher level.
So it's more intuitive, more structured.
Exactly. More structured, often faster, and ideally less error-prone. It dramatically reduces that engineering effort we were just talking about.
And is this catching on? Are people actually using it?
Oh, yeah. That efficiency gain, that's why we're seeing such broad adoption. This isn't just some academic idea. It's being actively used by big industrial players, companies like ExxonMobil, ABB, Noja J Power, and beyond just industry. It's integrated into university courses, research institutions all over the world. Austria, Japan, you name it. It shows real-world impact, global recognition.
That real-world impact is fascinating. Let's maybe zoom in on one example. You mentioned something really specific, agriculture. Using 4diac Forte with Isobus. That sounds unexpected.
It is a pretty neat application, yeah. Isobus, that's the ISO 15183 standard. It's basically the universal plug-and-play standard for tractors and farm implements. Combining 4diac Forte with Isobus creates, effectively, a low-code platform for Isobus.
Low code for tractors.
Kind of, yeah. And it's specifically targeted at what they call batch size 1 agricultural machines.
Batch size 1, meaning unique custom machines.
Exactly. Highly customized individual machines. Imagine a farmer needing, I don't know, a very specific type of planter or harvester designed just for their unique field conditions, their soil, their crops, not something off the shelf. This platform lets engineers build the control systems for those bespoke, intelligent farming tools much more efficiently.
And there's a concrete example.
There is. The world's first open-source slurry tanker.
Okay, an open source slurry tanker. You don't hear that every day.
Chuckle slightly. No, you don't. But it's real. A physical piece of complex agricultural machinery, traditionally very bespoke, very complex to control, now being developed using this open-source tech.
So what made that possible? What's the tech behind it?
Well, it shows this isn't just for light-duty stuff. The controller, the ECU, has got a dual-core Extensa LX6 processor, decent amount of memory, 16 meg flash, 8 meg RAM. It runs FreeTOS, a real-time OS. It integrates a proper CCI Isobus driver, uses 2 CAN buses for reliable communication, one internally, one for the main Isobus network connecting to the tractor.
Robust stuff.
Yeah, and the whole thing is explicitly designed for a harsh environment,
Ah,
which is exactly what you need out in the field, right?
Yeah.
Mud, vibration, temperature swings.
definitely. So the breakthrough is really proving that you can build these complex, custom, rugged machines on an open, flexible software foundation.
That's a big part of it, yes.
Okay, let's pull back a bit then, thinking bigger picture. It seems pretty clear that Eclipse 4diac and this IEC 61499 standard, they're not just niche tools. They feel like key enablers for that whole Industry 4.0 concept we hear so much about.
Oh, absolutely. They're foundational technologies for this revolution in manufacturing.
How so? What's the direct link?
Well, Industry 4.0 is all about real-time control, hyper-efficiency, seamless integration of everything in a smart factory, right? These technologies, 4diac and 61499, they provide the actual framework to do that.
Yeah.
They enable the interconnected, intelligent machines, the distributed control, the flexibility that defines this new era.
You know, it makes me think of that Steve Jobs quote, something like, a computer is like a bicycle for the mind.
I know the one.
Mm-hmm.
The most remarkable tool.
Yeah, it amplifies our innate abilities. And I kind of feel like tools like 4diac are doing that for industrial control. They're taking something incredibly complex and making it more accessible, more adaptable, amplifying what engineers can achieve.
That's a great analogy. And that amplification, it keeps pushing boundaries. Look at something like Zentara.
Zentara, what's that?
It's a real-time middleware platform, and it's explicitly powered by 4diac Forte. So it shows how 4diac isn't just for today's automation tasks. It's forming the bedrock for more advanced systems integrating machine learning interfaces, smart sensors, connecting securely to cloud data spaces. It's enabling that next generation of really intelligent, really interconnected industrial systems.
So there you have it. We started with Eclipse 4diac and IEC 61499, and what we've uncovered is, well, a really robust open source solution that seems to be fundamentally changing the game in the complex world of cyber-physical systems. It's drastically cutting down that software development headache, making industrial innovation more accessible, and really opening up new possibilities across all sorts of industries, from fields to factories.
It really is quite transformative. And maybe that leaves us with a final thought to chew on. If complex industrial control can be made this much more accessible, this efficient, using open standards and smart tools, what's next? What other frontiers of automation, of innovation might unlock, not just in factories, but maybe elsewhere? What does a future look like, where designing and programming custom intelligent machines becomes almost as straightforward as using a personal computer, where the main limit is just our imagination?